Coming up on SpaceTime, the brightest gamma-ray burst ever seen, a comprehensive map of some 85,000 volcanoes on Venus, and NASA's Mars Perseverance rover begins its next science campaign on the Red Planet. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers around the world have been stunned by the brightest gamma-ray burst ever seen. A report in the astrophysical journal Letters shows that this blast was some 70 times brighter than any other gamma-ray burst ever detected. The event, catalogued as GRB 221009A, was first detected on Sunday, October 9, 2022, as it swept through the solar system with an intense beam of radiation so bright that scientists quickly dubbed it the boat, meaning brightest of all time. Gamma-ray bursts are the most powerful explosions in the universe since the Big Bang, some 13.82 billion years ago. These blasts release as much energy in a few seconds as what the Sun will produce in its entire 12 billion year lifespan. Gamma-ray bursts were first detected during the 1960s. They were picked up by American spy satellites that were monitoring the Soviet Union's compliance with nuclear test ban treaties during the height of the Cold War. Atomic bombs give off powerful blasts of gamma radiation during their detonation, which these satellites were designed to detect. And they were detecting hundreds of these blasts every year, not in the atmosphere, but out in deep space beyond the moon. Not only did this mean the Soviets were cheating on the treaty, that wasn't surprising as communists already had a long history of breaking agreements, but it also implied that they must have hundreds, possibly even thousands of spare nuclear weapons for these tests, far more than the West. It also meant they must have had hundreds of spare rockets to launch these bombs deep into space for testing, and they could do it both far more reliably than the United States and without the West detecting the launches. Now, if all this was true, it meant the Kremlin's technology was so far ahead of the free world, the West might never be able to catch up. The Cold War was already over, and the communists had won. The Pentagon quickly declared the whole thing a top secret while the military considered its next course of action. Now, luckily, eventually the Pentagon asked astronomers to take a look at the data. The astronomers quickly determined that these events were taking place billions of light years away, far beyond any human technology, and certainly beyond the capabilities of the Soviet Union. The crisis was over, but the cause of these extraordinary gamma-ray bursts would remain a mystery for decades to come. Slowly, over time, astronomers put together the missing pieces of the puzzle. We now know that gamma-ray bursts can have two different origins. Short-period gamma-ray bursts, which usually last less than about 2 seconds, these are hypothesized to be produced by the merger of two neutron stars in a close binary system. When the neutron stars merge, they generate a kilonova, an unusually powerful type of supernova explosion, in the process forming one of the strangest and most mysterious objects in the universe, a black hole, a place of infinite density and zero volume where the laws of physics as science understands them no longer apply. Then there are long-period gamma-ray bursts, usually lasting more than 2 seconds. These are hypothesized to be generated by the core collapse death of the universe's largest stars in hypernova or superluminous supernova explosions. You see, when really massive stars, far bigger than our Sun, exhaust their nuclear fuel supplies needed for core fusion, the process which makes stars shine, they suddenly collapse in on themselves, triggering a supernova explosion. Usually what's left behind is a small super-dense stellar remnant called a neutron star, which forms when protons and electrons at the stellar core are crushed together, forming neutrons. However, if the star was massive enough, it could collapse beyond the neutron star stage, marking the birth of a stellar mass black hole, or alternatively, a highly magnetized type of neutron star called a magnetar. During this process, two enormous jets of energy-emitting plasma burst out from the stellar core. And if one of those extremely bright jets just happens to be pointed towards the Earth, the afterglow can be detected by both ground and space-based telescopes, even at cosmological distances. This material doesn't simply catapult out of the exploding star. It seems to actually accelerate to ultra-high superluminal speeds along the narrow beam of the gamma-ray jet, which leaves scientists somewhat puzzled over the power source driving these extraordinarily powerful events. There have been many hypotheses to try and explain the mysteries of these gamma-ray bursts. Many astronomers believe in the baryonic jet model, in which the phenomenon is caused by repeated violent collisions between material blasted out during the explosion and the material surrounding the dying star, resulting in a gamma-ray flash and the subsequent fading afterglow. However, another idea, called the magnetic model, suggests that a huge primordial magnetic field in the progenitor star collapses within seconds of the initial supernova explosion, releasing the energy needed to power the prodigious blast. Whatever the true cause, the boat triggered detectors on numerous spacecraft, and observatories around the world were swung into action to follow up. After combing through all the data, astronomers can now characterize just how bright this explosion was, and they can better understand its scientific impact. The study's lead author, Eric Burns from the Louisiana State University in Baton Rouge, says JRB 221009A was likely the brightest burst in X-rays and gamma-ray energies to have occurred since the very dawn of human civilization. He led an analysis of some 7,000 gamma-ray bursts, mostly detected by NASA's Fermi Gamma-Ray Space Telescope and the Russian Kronos instrument on NASA's WIND spacecraft, in order to establish how frequently events this bright could occur. And the answer was only once every 10,000 years. In fact, this burst was so bright, it effectively blinded most gamma-ray instruments in space, which means they couldn't directly record the real intensity of the emission. Instead, astronomers had to reconstruct the details using the Fermi data. They then compared their results with those from the Russian teams working on the Kronos data and with Chinese teams analysing their own observations. And it was that combined independent research which proved that this burst was some 70 times brighter than anything previously seen. Observations of the burst span the entire electromagnetic spectrum, from radio waves and infrared right through the visible light spectrum into ultraviolet, X-rays and gamma rays. And it includes data from many NASA and partner missions, including the NICER X-ray telescope on the International Space Station, NASA's New Star Observatory, and even the Voyager 1 spacecraft deep in interstellar space. Papers describing the results appear in a special focus issue of the Astrophysical Journal Letters. The signal from GRB 221009A has been travelling through space for about 1.9 billion years before it reached the Earth. That might sound like a long way off, but it actually makes it one of the closest known long-period gamma-ray bursts ever recorded. We think that as it quickly ingests the surrounding material, the newly born black hole blasts out jets in opposite directions containing particles accelerated to near the speed of light. These jets quickly pierce through the remains of the star, emitting X-rays and gamma rays as they stream deep into space. Now, with this type of gamma-ray burst, astronomers normally expect to find a brightening supernova a few weeks later. But so far, nothing's been seen. Now, one reason for that could be that this particular gamma-ray burst appeared in a part of the sky that's just a few degrees above the plane of our own Milky Way galaxy, where the thickest dust clouds are, dimming the light from incoming sources. However, one of the study's co-authors, Andrew Levin from Radboud University in the Netherlands, admits that the team cannot conclusively say that there is a supernova associated with this blast, which is surprising given its brightness. Since the dust clouds become more transparent at infrared wavelengths, Levin led near and mid-infrared observations using NASA's James Webb Space Telescope, its first use for this kind of study, as well as the Hubble Space Telescope, to try and spot the growing supernova. Now, Levin says if it's there, it's very faint, because he hasn't been able to spot it yet, even with these great space telescopes, so he's going to keep looking. But there's also the possibility that the entire star simply immediately collapsed straight into the black hole instead of exploding. Additional Webb and Hubble observations are planned over the next few months. We'll let you know what happens. Meanwhile, as the jets continue to expand into material surrounding the doomed star, they're producing a multi-wavelength afterglow, which is gradually fading away. Now, being so close and so bright, the burst offered scientists an unprecedented opportunity to gather observations of the afterglow across the electromagnetic spectrum, and to test how all current models reflect what's really happening inside these gamma-ray burst jets. However, that's produced a bit of a problem. It seems 25 years of afterglow models, which have worked really well until now, can't completely explain what this jet's doing. It includes a new radio component that the authors don't fully understand. Now, this may simply indicate additional structure within the jet, or it may show the need to revise current models on how gamma-ray burst jets interact with their surroundings. The jets themselves weren't unusually powerful, but they were exceptionally narrow, sort of like the jet sitting on a garden hose pointing directly at us. So the closer to head-on you view the jet, the brighter it appears. Although the afterglow was unexpectedly dim at radio energies, it's likely this gamma-ray burst will remain detectable for years to come, providing a novel opportunity to track the full cycle of a powerful GRB jet. This burst also enabled astronomers to probe distant dust clouds in our own galaxy. See, as the X-rays travel towards the Earth, some of the energy is reflected off dust clouds, creating extended light echoes of the initial blast in the form of X-ray rings expanding from the burst's location. The X-ray telescope at NASA's Swift Space Observatory discovered the presence of a series of these light echoes. And detailed follow-up observations using the European Space Agency's XMM Newton Space Telescope, together with the Swift data, revealed that these extraordinary rings were produced by 21 distinct dust clouds. Exactly how dust clouds scatter X-rays depends on their distances, the size of the dust grains, and the X-ray energies. Astronomers were able to use the rings to reconstruct part of the burst's prompt X-ray emission and determine where in the Milky Way galaxy the dust clouds were located. Now, GRB 221009A is only the 7th gamma-ray burst to display X-ray rings, and it triples the number of rings previously seen around one. The echoes come from dust located between 700 and 61,000 light-years away. The most distant dust echoes, clear on the other side of the Milky Way galaxy, are also about 4,600 light-years above the galaxy's central plane where our solar system resides. Lastly, the burst offers an opportunity to explore a big cosmic question. We think of black holes as all-consuming things, sucking up anything that gets too close. But can they also return power back to the universe? The authors were able to probe the dust rings using NASA's Imaging X-ray Polarimetry Explorer spacecraft in order to glimpse how the prompt emission was organized, which can give insights into how the jets formed. And a small degree of polarization observed in the afterglow confirms that we actually view these jets almost directly head-on. Together with similar measurements now being studied by using data from ESA's Integral Observatory, scientists say it may be possible to show that the boat's jets were powered by tapping into the energy of a magnetic field amplified by the black hole's spin. James Leung from the University of Sydney was part of a team that undertook follow-up observations of the burst using ASCAP, the Australian Square Kilometre Array Pathfinder radio telescope located in outback Western Australia. Leung is one of the authors of a complementary study currently published on the pre-press physics website archive.org and slated for publication in the journal Nature Astronomy. He says the exceptional brightness of the gamma-ray burst meant astronomers were able to study it in unprecedented detail in real time, as the light was arriving from the distant galaxy. It gave astronomers a golden opportunity to test intricate physical models which describe what happens before, during, and after the death of a star.
So gamma ray burst is essentially what happens when a very, very massive star dies. And when these massive stars die, they explode in a fantastic explosion. And a gamma ray burst is a particular type of explosion where upon the star dying, they launch two really, really high-speed jets in the polar directions. And what we see from those jets are the gamma rays, and that's why we call it a gamma ray burst.
Now we know there are two types, long burst and short period. This was a long period one. Tell me about it.
Yeah, that's exactly right. So this one is a long-period gamma ray burst. And so these gamma ray bursts are split into two two classes, really. The short ones are what we now know come from the merger of two neutron stars. So these are very, very dense, heavy stars colliding with each other. And that was sort of associated with gravitational waves, which was quite big in the news a couple of years back. But what we saw last year in October was a long-duration gamma ray burst. So these bursts last a bit longer than the short ones. And essentially what they come from the death of a massive star. So unlike the merger of two neutron stars, this just comes from one extremely massive star reaching the end of their life, and they reached the end of their life through a supernova and then a gamma ray burst that comes roughly the same time.
You're part of the team that was observing this event. What were your observations involving?
Yeah, so I was part of the team in Australia that pointed the radio telescopes at this event. And really what was amazing about this event was how bright and how close it was. It allowed us to observe this event in unprecedented detail. And so our team, as part of a global team, was able to follow this event from very, very, very early on in the radio. And so we were using the ASCAP telescope in Western Australia to do this. And essentially what this tells us is what's happening in these jets very, very early on. That's information that's really important to know because these jets are launched at really, really high relativistic speeds, or really, really speeds very close to the speed of light. And so it's really important that we know what's going on at a very early time, and I think our work contributed to that.
Any evidence of a supernova? Normally when you think of stars exploding, one thinks of supernovae associated with that. What's the story with this particular one, however?
Yeah, so this one was quite a strange one in the sense that usually with these long period gamma ray bursts, we do expect to see a supernova alongside it. And that's actually how we confirmed that these long duration gamma ray bursts come from the death of an extremely massive star. And so this supernova long gamma ray burst connection has been quite well established. But from this particular gamma ray burst, we haven't actually seen a sign of a supernova yet. That's quite odd, and people have their different theories as to why that might be the case. And I think one of the reasons is because where it's located in the sky, it's located very, very close to the galactic plane, and so there's a lot of dust that's along the line of sight. And that might be contributing to why it's hidden for now.
When a gamma ray burst happens in the sky, there's not much time to get things organised. So there's got to be a set routine that's been well practiced and laid out in advance, because all of a sudden you get all these telescopes all over the world stopping what they're doing and then slewing across to focus on this one event. What was happening with you guys?
Right, so generally what happens is there is an alert system for these type of events, and astronomers who study gamma ray bursts around the world subscribe to this alert system. And so when this really, really bright one came in, it popped up an alert system to inform astronomers that this could be a gamma ray burst with that's a very, 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 very bright, or it could be something else. At the time, it was not very, very clear, but a few hours later, it's confirmed that it is a gamma ray burst. And then there became a lot of interest from the community. And so when that happens, astronomers generally activate their telescopes to point at it. And so we were no different. We saw the event, and then we knew that if we were able to get our radio telescope onto the event early, we're going to have a lot of great science that comes from it. And that's what we did. And to do that, there are protocols in place to do that. What we would do is we will put in proposals, which are scientific justifications as to why a certain science case deserves to use the telescope. And very often these proposals are written in advance in anticipation of something like this happening. And so this is sort of the process that myself and also astronomers around the world have gone through, and how they activate the telescope to point it all onto the gamma ray burst in such a timely manner.
And this was not just some ordinary burst. This was what's being described as a 1 in 10,000 year event. Is that because it was so bright, or because it was so close, or a combination of the two?
Right. That's exactly right. It's a combination of the two. And so it is only slightly brighter than, slightly more luminous than the second most luminous GRB, and it is not by any means the closest GRB. We've got a handful of gamma ray bursts which have been detected to be closer to Earth. What makes it really special is that it's the combination of the two. It's both extremely bright and extremely close. And when we do the maths, and one of the studies do show that it's once in every 10,000 years indeed.
What's the difference between brightness and luminosity? Is it luminosity being intrinsic energy as opposed to brightness being apparent amount of light?
Yeah, so that's essentially what I'm getting at. So when I was talking about the luminosity, it's the intrinsic radiation that's given off by the source, whereas the brightness, what I'm referring to, is a factor of how intrinsically how bright it is, but also how far away we are from it. So if we're closer to it, then the thing will appear brighter. If we're further away from it, the thing will appear dimmer. And that's what we call the brightness. But no matter how far we are from it, intrinsically, how luminous it is doesn't change.
It's like looking at a bunch of streetlights down the road. We know they're all the same luminosity, but the ones nearest appear brighter.
That's exactly right.
Are you among the scientists waiting for Betelgeuse to go supernova?
Well, no. I'll be very, very, very keen to study and see what's going on, but this is not something that I'm actively losing sleep over.
What will happen when a gamma ray burst goes off in our neck of the woods, and suppose it's pointing towards us? What are we likely to see first?
So it really depends on how close it is. If it is very, 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 very close in our galaxy, then and it is pointed towards us, what you'd have is the atmosphere essentially being stripped, and then you're basically going to get a mass extinction event. That's because the gamma rays are ionizing, the atoms and the molecules in the atmosphere. But if it was a bit further away, say maybe in the edge of the galaxy, then what might happen is that the electronics all get interfered, and you might have a shutdown of a lot of the communications around the world, which will be quite disastrous in a sense. But having said that, it's very unlikely that one of these happens in our galaxy just because of how often they happen. The very, very close gamma ray burst we saw last year was 1,000 times the distance of our closest galaxy. And so having something that's so much more closer is highly unlikely, and actually the angle of the beam is actually very, very small. So it's actually about, somewhere around 5 degrees. So if you think of a circle of 360 degrees, it's very, very unlikely, even if it were to happen in our galaxy, that it's pointed towards us. So I don't think that's something that we should worry too much about.
Do we know anything about the progenitor star at this stage?
Well, we know that because it's a long gamma ray burst, we think that it's a very, very heavy star that has collapsed into a black hole. Beyond that, so this is still ongoing studies, and some studies have been showing that this gamma ray burst happened in a very, very windy environment that's swept up by the progenitor before it died, and that's often the case for these long gamma ray bursts. Beyond that, still a lot of work being done on these investigations. What we saw in March was just the first splash of these data papers, and a lot of the teams now are then studying all the data that's there, and trying to figure out a better understanding of what actually happened.
That involves what? Things like obtaining spectra and that sort of thing.
So the data papers, they publish a lot of the initial data that leading up to the first couple of months of this year, but there's going to be ongoing observations for it. And also because now all the data is very public, then teams are able to aggregate this data and apply the different models to see what's going on and what fits the model best. And essentially from there, we sort of wiggle around to see what is the most likely interpretation for what actually happened last year.
That's astronomer James Leung from the University of Sydney. And this is SpaceTime. Still to come, a new comprehensive map plots the location of 85,000 volcanoes on Venus. And NASA's Mars Perseverance rover begins a new science campaign on the Red Planet. All that and more still to come on SpaceTime. A new study has mapped no less than 85,000 volcanoes on the planet Venus. The work, reported in the Journal of Geophysical Research Planets, follows the recent discovery of current volcanic activity on that strange heat-soaked world. One of the study's authors, Paul Byrne from Washington University in St. Louis, says the new map could help scientists locate the next active lava flow by providing the most comprehensive map of all volcanic edifices on Venus ever compiled. It provides researchers with an enormously valuable database for understanding volcanism on Venus, a key planetary process but one little understood. Byrne, together with co-author Rebecca Hahn, used radar imagery from NASA's Magellan spacecraft mission to Venus to catalogue volcanoes across the planet on a global scale. The resulting database contains some 85,000 volcanoes, 99% of which are less than 5 kilometers in diameter. Since NASA's Magellan mission in the 1990s, astronomers have had numerous major questions about Venus's geology, including its volcanic characteristics. But with the recent discovery of active volcanism on Venus, understanding just where volcanoes are concentrated on the planet, how many there are and how big they are, all becomes far more important, especially since we'll have new data for Venus in coming years. Hahn says they came up with the idea for putting together a global catalogue of volcanism on Venus because no one else had done it on this scale before. Bernard Hahn's new study includes detailed analyses of where volcanoes are, where and how they're clustered, and how their spatial distributions compare with geophysical features and properties on the planet, such as crustal thickness. Taken together, this work provides the most comprehensive understanding of Venus's volcanic properties, and perhaps that of any world's volcanism so far. That's because although we know a great deal about the volcanoes on Earth, here we're primarily talking about the ones on land, and there's still a great lot of mystery about those under the oceans. Lacking oceans of its own, Venus's entire surface can be viewed with the Magellan radar imagery. Although there are volcanoes across almost the entire Venusian surface, scientists found relatively few volcanoes in the 20 to 100 kilometre diameter range, which may be a function of magma availability and eruption rate. They also wanted to take a closer look at smaller volcanoes on Venus, those less than 5 kilometres across that have been overlooked by previous volcano hunters. These are the most common volcanic features on the planet, representing about 99% of the entire dataset. The authors looked at their distribution using different spatial statistics in order to figure out if they're clustered around other structures on Venus or if they're all grouped in certain areas. The new volcano dataset is hosted at Washington University and publicly available for other scientists' use. While 85,000 volcanoes on Venus might seem like a large number, it's actually conservative. There are hundreds of thousands of additional geological features on Venus, many of which have volcanic properties, but they're simply too small to be picked up. For example, a volcano a kilometre wide in the Magellan dataset would only take up 7 pixels in that dataset, which makes it really hard to see. But with improved resolution, the authors should be able to resolve these structures. And that's exactly the kind of resolution future missions to Venus are likely to acquire in the 2030s. Both NASA and the European Space Agency are sending missions to Venus in the 2030s, and these will include very high-resolution radar images of the surface. And with those images, the authors should be able to search for all those smaller volcanoes, which right now they're just predicting are there. This is SpaceTime. Still to come, NASA's Mars Perseverance rover begins its next science mission on the Red Planet, and later in the science report, a revolution in battery power with new silicon anode platform batteries doubling the performance of lithium-ion technology. All that and more still to come on SpaceTime. NASA's Mars Perseverance rover has commenced a new science campaign on the surface of the Red Planet. The rover's collected new rock samples as it continues to explore the fan-shaped river delta, which has been the primary target of its mission in Jezero Crater. The new samples will be stored aboard the 6-wheeled car-sized rover's cache for eventual return to Earth for further study as part of a joint NASA-European Space Agency sample return mission. Scientists want to study the Martian samples using more powerful lab equipment available on Earth in order to search for signs of ancient microbial life and to better understand the water cycle that has shaped the surface and interior of Mars. With each campaign, mission managers are able to explore and investigate new areas. This one sees the rover exploring the top of the Jezero Crater Delta. Perseverance has now collected a total of 19 samples and 3 witness tubes, and it's recently deposited 10 of those tubes in a backup cache on the Martian surface. Taken from a rock the science team called Berea, the latest sample is the 16th cord rock sample of the mission. There have also been samples of regolith or broken rock and dust, as well as samples of the Martian atmosphere. The science team believes that bria formed from rock deposits that were carried downstream by an ancient river that once flowed into the crater, forming a vast lake billions of years ago. These sediments would have come from further upstream, well beyond the confines of Jezero crater, and it's one of the reasons why the team finds the rock so promising. Perseverance Deputy Project Scientist Katie Stack-Morgan from NASA's Jet Propulsion Laboratory in Pasadena, California, says this rock is rich in carbonate. And on Earth, carbonate rocks are good at preserving fossilized life forms. If there was life on Mars, there's a good chance biosignatures may have been present in the sediment. And if biosignatures were present in this part of Jezero crater, it could be a rock like this one that could very well hold their secrets. The primary goal of this mission is searching for signs of ancient life on Mars. Although it's a freeze-dried desert today, Mars was once a warm, wet world, one capable of supporting life as we know it. One of the big puzzles about the red planet is how the Martian climate worked back then when the area was covered in liquid water. Because carbonates form due to chemical reactions in liquid water, they can provide scientists with a long-term record of changes in the planet's climate. By studying the carbonate in the bria sample, mission managers could help fill in those gaps. Perseverance Project scientist Ken Farley from Caltech says the bria core highlights the beauty of rover missions. Perseverance's mobility has allowed scientists to collect igneous rock samples from the relatively flat crater floor during the first campaign. It then travelled to the base of the crater's delta region, where researchers found fine-grained sedimentary rocks deposited in a dried-up lake bed. And now the mission's sampling a geologic location where coarse-grained sedimentary deposits have been laid down. With this diversity of environments to observe and collect from, scientists are confident that these samples will provide them with a better understanding of exactly what occurred in Jezero crater billions of years ago. Perseverance is now continuing to climb the delta on its way to its next location, a bend in the dry riverbed called Castel Henleys. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study has warned that despite efforts to ban ozone-killing chlorofluorocarbons, concentrations have been increasing over the past decade, with China the primary contributor. The 2010 Montreal Protocol banned the production of most CFCs previously used as refrigerants, solvents, and aerosol propellants. Some are still allowed for the production of other chemicals, such as hydrofluorocarbons. Some are still allowed for the production of other chemicals, such as hydrofluorocarbons. A report in the journal Nature Geoscience has used global data to estimate 5 CFCs, showing they've increased in the atmosphere between 2010 and 2020, and 2 of these CFCs have no current known uses. In 2018, factories in communist China were found to be the source of a major spike in illegal CFC production. A California-based company has started production of a lithium-ion cell battery, which is delivering an unprecedented energy density of some 500 watt-hours per kilogram. That's some 1,300 watt-hours per litre, and double the performance of existing commercially available lithium-ion batteries. The new Amphia silicon anode platform provides a runtime of 200% compared to state-of-the-art graphite cells, while being both lighter and smaller than other batteries with the same energy content. And it's not hype. The new battery's performance claims have already been independently verified by Mobile Power Solutions, confirming its unprecedented energy density. The reported downside of all this is slower charging times, around 10 hours. Initial production at a new plant being built in Colorado is expected to be for US government contracts. That'll be followed by meeting the aviation's requirements for drones and light aircraft, and then for automobiles. A new study has concluded that most methods to reduce a person's conspiracy beliefs simply don't work. A report in the journal PLOS ONE reviewed 25 papers, which have included over 7,000 participants, finding that only about half of all efforts achieved any sort of change in a person's conspiracy beliefs. The authors found the most effective interventions point out the factual inaccuracies of a particular conspiracy theory before people were being exposed to it, as well as being exposed to programs where people are taught critical thinking so they can differentiate between scientific and pseudoscientific practices. Well, despite all the claims to the contrary, there's actually never been a scientifically proven case of spontaneous human combustion. Yet the stories keep persisting. The idea is that a person can be sitting alone in a room, not doing anything special, and then suddenly bursts into flames. Tim Mendham from Australian Skeptics says the simple truth is, despite all the scientific and technological advances, some cases of death, such as what we call spontaneous human combustion, remain mysterious.
Well, spontaneous human combustion is, supposedly, the situation where someone just bursts into flames from the inside. There's no external source to set them on fire. They just sort of heat up, the body heats up in some place, or suddenly they start breathing out fire, or their flesh starts burning, etc. That's the theory, okay? No one's seen it happen as far as I know. Sorry, there's one case where someone claims to have seen it happen, but there might be other explanations because witnesses to all these things is very unreliable. So there's been cases quoted over hundreds of years, basically, of coming across a body and finding it just burnt, sitting in a chair or something. It's often sitting in a chair in a lounge room or something, and the body is turned to ashes, apart from perhaps little pieces of it. It's often feet or lower legs. Everything else is ash, and they can't see any other evidence of burning around the room they're in. So naturally, because you come across a situation like that, you assume spontaneous human combustion straight away, which is a bit of a jump. Looking at stuff recently, looking at the examples, in many cases, you can find potential reasons for why these things happen. Obviously, a lot of people smoke and they fall asleep and set themselves on fire. So the clothes do burn along with the body. And what happens is that if a body burns, all the fat becomes like wax. Yeah, like a candle wax. So it doesn't necessarily spread out a long way. It just sort of goes blobby and sort of turns to ash eventually, as you see a candle does. And the clothes they're wearing might act as an external wick, or might be, I don't know, and therefore it burns down. And then it gradually burns out, as a candle might sort of snuff itself out before it's finished burning, right? And it doesn't necessarily burn things around it. The interesting thing is some people sort of say they were sitting in a chair, the chair wasn't burnt, or something, which is actually rarely true. But therefore, most of the examples you can try and figure out, because you weren't there, so you don't know for sure, but most of the things you can try and figure out were probably someone smoking, drinking, someone set them on fire or something, but yeah, it's accidents really. And then there's the others where you don't know, and I'm reading a recent article which was looking into a number of cases. They say, when you don't know, you don't know. Saying you don't know doesn't mean you have to come up with an answer. You just say, I don't know, and you have to leave it at that. There are unexplained mysteries out there. So whether it's falling asleep and smoking, or drinking too much and setting yourself on fire, or sitting too near a fireplace and setting yourself on fire that way, people do burn, and people do burn on their own in the middle of the night, and you come down and you find grandma in a heap of ashes.
Oh, no.
And it does happen like that. But whether it's spontaneous human combustion, there's no evidence to suggest that that's the case. There is only mysteries, and mysteries that have been filled by other people with a suggestion. I don't know what it is, therefore it's a flying saucer. I don't know what it is, therefore it's spontaneous human combustion. Whereas really, if you don't know what it is, you don't know what it is, and you've got to leave it at that. So therefore, yes, people do burn. People do burn in strange ways. People do burn like a candle and don't burn necessarily things around them. There might be a little bit left, often the foot.
Is that just because there's less fat on the foot usually?
It probably is. There's fat. Often they're clothed in something tight, shoes, etc. Right, and that tends, or they just sputter out like a candle does. You probably get down to the end of your candly bit and you find yourself that with the last bit's not worth burning. Whatever the reason, I don't know, because people don't see it. And when they do see it, there's one example in this article I read recently. It's almost like a suggestion of a story that grows in the telling. And one person says, I don't know what happened, and someone else says, this person smoked all the time and drank all the time. He's probably just spilled it over himself and burst into flames. That happens too. So it's an interesting phenomenon. Only when you see it in the results, no one's seen it in action really. So you have to sort of try and say, well, what's the most likely cause? Using Occam's razor, you find the one that's least complicated explanation, the one that most fits in with your understanding of science and the world, and the one that crops up all the time is probably set themselves on fire by accident.
That's Tim Mendham from Australian Skeptics. that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.